Hello, this is Dr. Brown. This video is going to help you to review for test 2. Before we start working the first problem, and I hope you have taken a copy of this extra practice that I've sent you and have this out, and maybe you've already tried to work some of these problems. I'm going to work them all. The very first thing I wanted to say was that you need to know how to take derivatives. You need to also understand that if you have S's position, that the velocity is equal to the first derivative of the position, and that the acceleration is equal to the derivative of the velocity, which is the second derivative of the position. You need to know differentiation rules. Differentiation rules, like the very simple, if you have x to the n, that its derivative is nx to the n minus 1. You need to also know the product rule and the quotient rule. And how to use them. Then you need to know the chain rule, which really means that if you have y is equal to a function of u, but u is also a function of x, then if you want to take dy dx, you first take dy du and multiply it by du dx. The bottom line is you're never finished taking a derivative until you've taken into account every function that you see in the expression. And then finally we're going to be looking at trig functions, and derivatives of like y equal ln of x. Now, and then finally we're going to wrap up and look at related rates. So the first problem here is to find the derivative of the function t cubed minus 8t squared and calculate its derivative at the point t equal minus 3. So using our very first rule here, we get s prime is equal to 3t squared minus 16t, and then we evaluate it at the point minus 3 and plug in minus 3. So we have 3 times minus 3 squared minus 16 times minus 3. Do the arithmetic and we get 75. Number 2, we want to do another simple derivative, and using the same rule, we get 4 times 4 is 16 times x cubed minus 3 times 20 times 9 is 27 times x squared, and of course the derivative of minus 3 is 0, and that is answer B. Number 3, we have minus 2 times 13 is minus 26 times x to the minus 2 minus 1 is minus 3. Minus 3 times 9 is minus 27 times x to the 3 minus 1 is x squared. And then finally, the derivative of 5x is 5. And that answer is answer B. Now we want to find the second derivative here, and I caution if you see one like this with x in the denominator, and you can simply flip it over, do that so you'll have x in the numerator. So we rewrite it as 1/7 x to the minus 2 plus 1/11 x to the minus 1. And now we take the first derivative and get minus 2/7 x to the minus 3 minus 1/11 x to the minus 2. And now we're ready to take the second derivative, which is minus 3 times minus 2 is 6 divided by 7 x to the minus 4. And then minus 2 times minus 1/11 is 2/11 x to the minus 3. And then rewriting it with the exponents, or with x in the denominator, and we get 6 over 7x to the 4th minus 2 over 11x cubed. And that is answer C. Now here's one in which you might jump on and say, we'll use the product rule, but sometimes it's a lot simpler just to FOIL everything and multiply it out and then take the derivative. So first FOILing, you get 36x squared plus 6x minus 18x minus 3. And now combining everything, we get 36x squared minus 12x minus 3. Taking the derivative, we get 72x minus 12, and that is answer D. This is an example. If you just take a look at it, you can simplify things by multiplying out first. And notice if you FOIL it, you get x squared. The inside is 1 over x times x, which is 1. And the outside is minus 1 over x times x, which is minus 1. Notice that that turns out to be 0. And then the last term is minus 1 over x squared. We'll rewrite that as minus x to the minus 2. Now we'll take the derivative. The derivative of x squared is 2x. The derivative of minus x to the minus 2 is plus 2x to the minus 3. And rewriting it, we have this, and that is answer C. Now this particular one, there's no easy way around it. The best thing to do is just go ahead and use the quotient rule, and that says that you take the denominator times the derivative of the numerator, which is 2x minus 3, then minus the numerator, which is x squared minus 3x plus 2, times the derivative of the denominator, which is 7x to the 6, all divided by the denominator squared. Now we go ahead and multiply out to simplify. and we get 2x to the 8th minus 3x to the 7th minus 4x plus 6. Then we distribute the minus 7x to the 6th, and we get minus 7x to the 8th plus 21x to the 7th minus 14x to the 6th, all divided by x to the 7th minus 2 quantity squared. Now we combine the x to the 8th terms, and we get minus 5. We combine the x to the 7th term, which is minus 3 plus 21, gives you plus 18. And then the next term would be minus 14x to the 6. There's only one x to the 6. And then minus 4x plus 6, all over x to the 7th minus 2 quantity squared. And that is answer D. We have another one in which we need to use the quotient rule. So again, it's the denominator 2e to the t plus 1 times the derivative of the numerator, which is 4e to the t, minus 4e to the t times the derivative of the numerator, which is 2e to the t, divided by the denominator squared. Now multiplying all of this out, we get 8e to the 2t plus 4e to the t minus 8e to the 2t, and notice that this cancels out, and we get 4e to the t divided by 2e to the t plus 1 quantity squared, and that is answer C. Now let's find the derivative of this function. It's a product of two different functions, and we'll say the first will be called 7x squared, and the second would be e to the x. So the product rule says the derivative is the first times the derivative of the second. The derivative of e to the x is e to the x, plus e to the x, which is the second, times the derivative of the first, which is 14x. And now we will put the 14x out in front of the e to the x, and we get 14x e to the x plus 7x squared e to the x. That is answer B. Now we want to find the second derivative of this function. And the first thing to do is to rewrite this to make it easy for us. You could use the product rule or the quotient rule, but it's probably easier to go ahead and rewrite it. And notice that this whole term is 2 over x to the 9th minus 2x squared over x to the 9th plus x to the 5th over x to the 9th. And rewriting it, we get 2x to the minus 9 minus 2x to the minus 7 plus x to the minus 4. Now take the first derivative. We're going to get minus 18x to the minus 10 plus 14x to the minus 8 minus 4x to the minus 5. Now taking the second derivative, which is just taking the first derivative of the first derivative, we get 180 x to the minus 11 minus 8 times 14, which is minus 112, x to the minus 9, and then finally minus 4 times minus 5 is 20, x to the minus 6, and now we rewrite this with the x having positive exponents, and we get what you see here, and that is answer A. Here again, we want to find the second derivative of this function. We get 2x to the minus 5. Doesn't have to be rewritten, but we rewrite the second one as minus 9x to the minus 1. Take the first derivative, we get minus 10x to the minus 6 plus 9x to the minus 2. Rewriting it, we get minus 10 over x to the 6 plus 9 over x squared. But since we need to take a second derivative, we didn't even have to rewrite that. Well, yeah, we do, because it's asked for the first derivative. So this is the first derivative. And then the second derivative, we just use this function and take another derivative and get 60x to the minus 7 minus 18x to the minus 3. Now we have a function of s. We need to rewrite this as 4s to the minus 3 minus 9s to the minus 1. Taking the derivative, we get minus 12s to the minus 4 plus 9s to the minus 2. And rewriting this, we get minus 12 over s to the 4th plus 9 over s squared. And this is answer D. Now here we want to take the second derivative, so we want to take the first derivative first, which is 12x plus 10 minus 9x to the minus 4th. Second derivative would be 12. The derivative of 10 is 0. And then finally, the derivative of the last term is 36x to the minus 5. And that is answer B. Notice that in this case, they decided not to write that as 36 over x to the 5th, which is fine. By the way, your calculator or computer can take either term. Now, number 14, we want to find the first derivative and I was a little bit confused here. Because it looks like we're taking the second derivative, and the answer they've got is for the second derivative. So let's go ahead and do this problem. I found that the easiest way is to multiply everything out first. And I get 1 over x squared times x squared is 1. 1 over x squared times minus 1 over x squared is minus 1 over x to the 4th. 1 over x squared times 1 is 1 over x squared. And then 1 times x squared is x squared. 1 times minus 1 over x squared is minus 1 over x squared. And then finally 1 times 1 is 1. So combining terms, we get 2. And notice that I have 1 over x squared minus 1 over x squared, so those cancel out. And then I rewrite minus 1 over x to the 4th as minus x to the minus 4. And then I have x squared. And now, this is a first derivative. There's no problem here. We're just doing first derivative. We've already done a lot of work, so it's almost like have already done a derivative, but we haven't. We have simplified the expression and ready to take the first derivative, which is 4x to the minus 5 plus 2x, and just rewriting it as 4 over x to the 5th plus 2x, and answer B is the answer. So this is the first derivative. I don't know why I had written that. That's the second derivative. This is just almost identical problem to one of the first ones. I should have probably not even picked it out. It's another quotient rule problem in which you take the denominator times the derivative of the numerator, which is just 5e to the t, minus the numerator, which is 5e to the t, times the derivative of the denominator, which is 2e to the t, divided by the denominator squared. Now multiply it all out, and you get 10e to the 2t plus 5e to the t minus 10e to the 2t. Notice these cancel, and you get 5e to the t divided by 2e to the t plus 1 quantity squared, and that is answer C. Second derivative again, just more work. The more problems you work, the better off you're going to be on the test. Notice we rewrite it as x squared plus 4x to the minus 2. Taking the first derivative, we get 2x minus 8x to the minus 3. To get the second derivative, take the derivative again, and we get 2. Minus 3 times minus 8 is 24. X to the minus 4. So finally, we get 2 plus 24 over x to the 4th, which is answer C. Okay, here's a problem. A ball is dropped from the top of a building, and they give you the equation of its height, which is S, or position. S equals 400 minus 16t squared. This in meters after t seconds. How long does it take the ball to reach the ground, and what is the ball's velocity at the moment of impact? Well, obviously, it's going to be on the ground when S is equal to 0. So set S equal to 0, and you get 16t squared equal 400, t squared equal 400 over 16. So t is equal to the square root of 400 over 16, which is 20/4, which is 5 seconds. Sorry about that. So to calculate the velocity when it hits the ground, we need to calculate the equation for the velocity, which is the first derivative of the position, which is minus 32t. The S prime at 5 is equal to 5 times minus 32 is equal to minus 160 meters per second, by the way, not feet per second. And this is answer 17, is answer D. 5 seconds to hit the ground, and it's going minus 160 meters per second. Now, we got to the area of a circular oil spill, which is A equal pi r square. It changes with the radius. At what rate does the area change with respect to the radius? Note this is not a relative rate problem with time. It has to do with, as the radius changes itself, how does the area change? So we just want dA dr, which is the derivative of the area with respect to the radius, which is 2 pi r, and at r equal 5, we get 10 pi foot square, which is area per unit radius, which is feet. And that is answer A. Now here is a very interesting problem. Probably be one similar to this on the test. This graphic shows the position, s, and velocity, which is the derivative of s, and the acceleration, which is its second derivative of s, or the first derivative of the velocity. And it's asking you, if this is a graph, which graph is which? Well, what you do know is the position will have another graph there that will be its derivative, and which would be the velocity, and then the velocity's derivative should be there also. So let's take a look. Let's just suppose we thought that this was position. If this were the position, its derivative is 0 here, and notice that the straight line goes through 0 at the same value of x. If that was position, then this would be velocity. However, if that's velocity, its derivative is minus, it's a negative number, and this other one is not the derivative of the velocity. So we picked the wrong one. So let's go back and pick another one. The more you learn about this, probably the better you'll pick it at the very beginning. I purposely picked the wrong one to start off with. Let's say the more complicated function here is position S, which is C. And look at its derivative. Its derivative is 0 at this point, 0 at this point, and lo and behold, where its derivative is 0, there's another graph here that's going through 0. So that sort of makes sense that this could be the velocity, which is the derivative of the position. And notice that then if this is velocity, its derivative is 0 right here, and this straight line goes through 0. So this straight line must be acceleration. So we have that C is position, and B is velocity, and A is acceleration. And that is answer C. Okay, let's do a little quotient rule here. We want to take the derivative of y with respect to x, and here we have to remember the quotient rule. Let's take the first term and do it. That's the denominator, which is 6x, times the derivative of the numerator. Derivative of the numerator is cosine of x, minus the numerator, which is sine of x, times the derivative of the denominator. Derivative of 6x is 6, so that's just 6, all divided by the denominator squared, which is 36x squared. Then do the next one, and we get sine of x times the derivative of 6x, which is 6, minus 6x times the derivative of sine, which is cosine, all divided by the denominator squared, which is sine squared of x. Now let's go ahead and simplify this. The first term, I'm going to take a 6 out and get 6 times x cosine of x minus sine of x divided by 36x squared. And notice I'm going to divide a 6 into this 36 and get 6. And then the second term, I'm going to take a 6 out and have 6 times sine of x minus x times cosine of x, all divided by sine squared. Notice that the guys who worked this out decided not to take the 6 out, so they put 6 times sine of x minus 6x times cosine of x divided by sine squared. And then the first term here, after we divide the 6's out, is x cosine of x minus sine of x over 6x squared, and that is answer B. Now, here's a little bit different problem, but it's still taking derivatives and solving a trig function. This is why you might want to have your unit circle on the quiz, which I will have attached to the quiz. It says find all points on the curve y equal cosine of x between 0 and 2 pi where the tangent line is parallel to the line y equal minus x. Well, if it's going to be parallel to the line y equal minus x, the slope of the tangent line has to be minus 1 because this slope is minus 1. Well, the slope of the tangent line of the function is given by y prime, which is the derivative of cosine of x, is minus sine of x. So we set that equal to minus 1, and we get the sine of x equal 1. And this sine of x is equal to 1 only at pi over 2. So that function is at x equal pi over 2, cosine of pi over 2 is 0. So the point we're talking about is pi over 2 and 0. And if I could draw this, I'm going to draw cosine of x. This is 0, pi over 2, pi, and this is 2 pi. And notice that we said the point is pi over 2. And if I could draw a halfway decent tangent line, there it is right there, and that the slope of that tangent line is minus 1, just like we wanted. Now we're getting into the chain rule big time. I'm sure nobody wants to multiply this trinomial out 9 times and then take a derivative. So we have to use a chain rule. So first of all, we imagine that that was like u to the 9th or x to the 9th, and write down the derivative would be 9 times this u, which is this function here, to the power minus 1, which is 8. So this is our u, and now we have to take and multiply the derivative of u times what we've already gotten and that derivative is 6x plus 6x squared minus 1. So the answer to this is B. Everybody needs to be able to understand and use the chain rule, which is illustrated here. Number 23, we need to find the derivative of the function, which is a polynomial times an exponential function. We'll need to use the product rule. So we start out with the first and the second. So we take the first times the derivative of the second. The derivative of e to the x cubed is going to be e to the x cubed times the derivative of u, which is x cubed, which is 3x squared, plus the second, which is e to the x cubed times the derivative of the first, which is 12x squared minus 4x plus 8. And what we're going to do now is factor out e to the x cubed and multiply the 3x squared times this polynomial, and we'll get 12x to the fifth minus 6x to the fourth plus 24x cubed minus 18x squared. And then we're going to add to that this polynomial, or this quadratic, which is 12x squared minus 4x plus 8. And now, to simplify, we'll multiply, we'll let the e to the x cubed be at the end here, and we'll put polynomial at the beginning. We still have just 12x to the fifth minus 6x to the fourth minus 24x cubed, and then combine the x squared terms and we get minus 6x squared minus 4x plus 8. So the answer is B. Number 24, we need to find dy dx using implicit differentiation. We have the relationship here, 2xy minus y squared equal 1. And the first thing you do when you get ready to do implicit differentiation is take d dx of every term. So we take d dx of 2xy minus d dx of y squared equals d dx of 1. d dx of 2xy, since 2xy is a product, we need to use a product rule, so it's the first, which is 2x, times d dx of the second, which is dy dx, plus the second, which is y, times the derivative of the first, which is the derivative of 2x, which is 2. Then d dx of y squared is going to be 2y, which is the derivative of y squared with respect to y, times dy dx, the chain rule. And then d dx of 1 is 0. So now we're going to factor out dy dx out of these two terms, and we're left with dy dx times 2x minus 2y. And then we'll bring this term, the 2y, over to the right, and it'll become minus 2y. And now we can solve for dy dx is minus 2y over 2 times x minus y. Factoring out the 2, we get minus y over x minus y, which is also, if we make this minus y over minus y minus x, the negatives cancel and we get y over y minus x, which is answer C. Then problem 25 is another implicit differentiation problem, and we again take d dx of every term of the expression. d dx of xy plus d dx of x plus d dx of y equals d dx of x squared y squared. Now, the first term is a product, so we take the first x times the derivative of the second, which is dy dx, plus y times the derivative of the first, which is the derivative of x is 1. Then we take d dx of x, which is 1, and of course d dx of y is dy dx. And then finally on the right hand side we take d dx of x squared y squared. This is again a product, so it's the first, which is x squared, times d dx of y squared, which is 2y dy dx. And then the second part would be the second, which is y squared times d dx of x squared, which is 2x. Now we are going to look at all the dy dx's and collect them all on the left hand side. So factor out dy dx and we're left with x. We're left with 1 after we factor dy dx out of itself, and then we're left with minus 2x squared y, which is what we get if we factor dy dx out of that. And of course it becomes negative as we take it over on the left hand side. Then that is equal to what we have left, 2x y squared, which is this term. We'll bring the y over here and make it a minus y, and bring the 1 over to the right and make it a minus 1. And now we can calculate dy dx is 2xy squared minus y minus 1 divided by, and we're going to go ahead and put minus 2x squared y first on the bottom, plus x plus 1, and that's the answer, and it's answer C. Problem 26 is another implicit differentiation, and this expression is cosine of xy plus x to the 7th equal y to the 7th. So we take d dx of cosine of xy plus d dx of x to the 7th equals d dx of y to the 7th. So we get the derivative of cosine of xy is minus sine of xy, but because this is not simply x but xy, we have to take d dx of xy, which is x dy dx, plus y d dx of x, which is y, times 1, plus derivative of x to the 7th is 7x to the 6th, and that equals d dx of y to the 7th, which is 7y to the 6th dy dx. So now we need to multiply all of this out and separate out dy dx. So we get minus x sine of xy dy dx minus y sine of xy plus 7x to the 6 equals 7y to the 6 dy dx. Okay, so now I want to collect all the dy dx's on this side, so I will pull this over and make it positive. Factoring dy dx out, we get dy dx times 7y to the 6 plus x sine of xy equals 7x to the 6 minus y sine of xy. So now dy dx is just this divided by this, which is 7x to the 6 minus y sine of xy divided by 7y to the 6 plus x sine of xy. And that is C. Here we want to find the derivative of y with respect to x, and we have a natural logarithm function. You might remember that d dx of ln of x is 1 over x. So now let's do this. We have a product here, so it's the first times the derivative of the second. Derivative ln of x is 1 over x, plus the second, which is ln of x, times the derivative of the first, which is 7x to the 6. And the derivative of minus 1/3 x cubed happens to be minus x squared. So the answer is x to the 6, that's simplifying this, minus x squared plus 7x to the 6 ln of x. And that is answer A. Now we want to take the derivative of the inverse cosine function, except we're also going to have to use the chain rule, because it's not just inverse cosine of x, it's inverse cosine of 5x squared minus 4. Now, dy du, if u is 5x squared minus 4, is minus 1 over the square root of 1 minus u squared. Dy dx is going to be dy du times du dx. So, replacing u with 5x squared minus 4, we get minus 1 over the square root of 1 minus 5x squared minus 4 quantity squared times the derivative of u, which is 10x. So finally we get minus 10x divided by 1 minus parentheses 5x squared minus 4 squared, and that is answer A. Here again we have another inverse function, inverse trig function. It's inverse sine of u, where u is 1 over x to the 4th. So dy dx is 1 over 1 minus u squared. Well, u squared is 1 over x to the 4th. Then we have to multiply it by the derivative of x to the minus 4, which is minus 4x to the minus 5. And so we have minus 4 over x to the 5th. And now we need to simplify this. The square root of 1 minus 1 over x to the 8th is x to the 8th minus 1 divided by x to the 8th. Have minus 4 in the numerator, and notice x to the 5th is multiplying the radical here. So now the square root of x to the 8th minus 1 over x to the 8th is the square root of x to the 8th minus 1. The square root of x to the 8th is x to the 4th. We have x to the 5th here, so we can cancel out x to the 4th, and we're left with x times the square root of x to the 8th minus 1 divided into minus 4. And that is answer A. Now here's a related rate problem. Suppose that the radius r and the volume of a sphere is 4/3 pi r cubed. They're differential functions of t. Write an equation that relates dv dt to dr dt. Well, dv dt is ddt of 4/3 pi r cubed. What we have to do is take the derivative with respect to r first, and then use a chain rule and multiply it by dr dt. Well, ddr of 4/3 pi r cubed is 4 pi r squared. And of course we don't know what dt is. It might be known to us or measured or something, but the final dv dt is 4 pi r squared times dr dt, which is answer B. Now we're given that in problem 31, we're given that the kinetic energy K of an object with mass m and velocity v is K equal 1/2 mv squared. How is dm dt related to dv dt if K is a constant? So K is a constant. Now we need to calculate the derivative with respect to time of m and v, and we do that implicitly. So we take ddt of both sides of the equation, ddt of k equal 1/2, I took the 1/2 out, dd and ddt of mv squared. ddt of k, which is a constant, is 0. Leave the 1/2 out, and we have mv squared, which we need to take the derivative with respect to t. So it's the first, which is m, times ddt of v squared plus v squared times ddt of m. So all that equals 0. Now we have, if all that is equal to 0, then we can divide through by 1/2 and then have that this term is 0. And now we need to calculate m times ddt of v squared, which is 2v dv dt, taking the derivative with respect to v and multiplying it by dv dt, and then v squared dm dt. So we have v squared dm dt equals, taking this term over to the other side, we get minus 2mv dv dt. So dm dt is minus 2mv divided by v squared times dv dt, and notice you can factor the v out, and we end up with minus 2m over v dv dt. So that relationship is given here in C. dm dt is minus 2m over v dv dt. And all this is done using implicit differentiation. Now here is another related rate problem. Water is falling on a surface, wetting a circular area. The circular area is going to be, for a circle, to be pi r squared, and it's expanding at a rate of 5 millimeters squared per second. How fast is the radius of the wetted area expanding when the radius is 123 millimeters? So we need to get an equation for dA dt and relate it to dr dt. So we take A equal pi r squared, take d dt of both sides, and we get dA dt equals, first take the derivative with respect to r, 2 pi r times dr dt. We're given that dA dt is 5, r is 123 millimeters, so 2 pi times 123 times dr dt is 5, and we can calculate dr dt to be 5 over 246 pi, which if you multiply out and round to 4 decimal places is 0.0065 millimeters per second, and that is answer B. Piece of land is shaped like a right triangle. Two people start at the right angle of the triangle at the same time and walk at the same speed along different legs. So here is a person walking. His distance is x. The other one is going at the same speed, so his distance from the start is x. One goes, say, to the north, the other goes to the east. And the triangle form has an area A, and they say that that area is changing at 2 square meters per second. How fast are the people moving when they are 4 meters from the right angle? So when x equals 4, what is dx dt? In other words, if x is the position of the person, dx dt is the velocity of the person, or both people, since they're going at the same speed. Well, the area of this triangle is A equal 1/2 x squared. That's 1/2 the base times the height. So dA dt is the derivative of A with respect to x, which is x times dx dt. dA dt is 2, is given, and we want to know this when they are 4 meters from the right angle. So now we have 2 equals 4 times dx dt. So dx dt is equal to 1/2 meters per second, and that is answer A. Now, the last problem here is a related rate problem. And we have an actor on a stage. The actor is 6 feet. We say the position from the front of the stage is X. And with a spotlight right there at the front of the stage, the actor has a shadow that is depicted by being Y feet high. And we're saying that the actor is running towards the audience at 3 feet per second. That means that dx dt is -3. It's decreasing. X is, as he runs towards the audience, x decreases. So dx dt is -3. And we want to find out how fast the height of his shadow is changing. The height of his shadow is y, so we want to find out dy dt. Now, to get a relationship between y and x, we need to look at the geometry here and see that we have similar triangles. we have the large triangle, and we have the small triangle that are similar. So y over 20 is equal to the height of the actor divided by x, which is its distance from the front of the stage. Cross multiplying, we get xy equal 120, and y, the height of the shadow, is 120 over x. And we want to calculate dy dt. So dy dt is d dx of 120 over x times dx dt, the chain rule. d dx of 120 over x is minus 120 over x squared, then times dx dt. Plugging in for x equal 2, they want this when he's 2 feet from the front of the stage. So x squared is 4. dx dt is minus 3, so simplifying this, we get that the shadow is increasing at 90 feet per second. And that is the last of these review problems.